did we complete this question yesterday with the?
No.
Okay. Yeah, we did. We did because this was 0.375, right?
Yeah, we did.
Okay, so we did this one. Okay.
We did all of them.
So I want to go on to the next one. Okay, it's a very similar type question, and all of these are pretty similar. They're going to somehow give you a fixed number of trials. There's going to be a probability of successes, and then obviously you'll be able to find the probability of failures from that. And the event should be independent. Okay, so in this one it says a survey found that 1 out of 5 Americans say he or she visited a doctor in any given month. So right there, those are independent situations where the fact that maybe I go to the doctor has no bearing on whether Lucas goes to the doctor. All right. It says if 10 people are selected at random, find the probability that exactly 3 will have visited a doctor last month. Okay. So N and X are directly linked to one another. Okay. N is the number of trials, and X is then the discrete variable in which the value that it takes on is a number between 0 and N. Okay. So in this scenario, we have 10 people, and we're going to look at 3 of them. So 10 is your number of trials, and 3 is the specific discrete variable value that we're interested in. Okay. Now, P is the probability of success. Probability of success. So in this case, our success is identifying whether they went to the doctor. Okay. So what is the probability that somebody goes to a doctor? 1 out of 5, right? Okay. Now, that being said, 1 out of 5, it doesn't mean that we've only surveyed 5 people. We could have surveyed 10 people and it was 2 out of 10. We could have surveyed 3 or 15 people and it was 3 out of 15. The idea is that we are providing that the probability P here is 0.2, okay, out of the population. Does that make sense? Okay, so 0.2 is the P value, or the probability of success, and then Q would be what? 0.8. Okay, so P and Q are complements one another. Once you have that information, it's just a matter then of plugging it into the formula that says probability of X is equal to N factorial over N minus X factorial times X factorial times then P raised to the X times Q raised to the N minus X. Okay? And we talked yesterday that this thing here is the combination formula. Okay? And the idea there, I'm going to use Desmos to do this. We were watching Sports Center during lunch, so that was just still open. It's weird.
This song goes hard.
That's why I thought that was coming from Markley's. Okay, so in Desmos, and there's a couple different like Desmos versions of the calculator that you can use, the graphing one or just a scientific one. Either one, you're going to find where it says function. Click that. This one just comes straight out and gives you the permutation combinations. If you're in the graphing version, you got to click this keyboard down here, and then you got to go to functions, and then you got to go to stats, and then you see the NCR. Okay. Yes.
Do you know where Christina went?
Yes. So then NCR, when we click that, okay, we are going to have to, the way they type it in here is you put N first and then R second. And we get 120. So what that idea is if I have a group of 10 people, okay, how many people we got in here right now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so let's say that we kick Lucas out of this group. We got 10 people.
Can you?
Yeah, I can. So let's say we only have 10 people in here, and I ask you how many different ways can I take out of that 10 people a group of 3? Okay, does that make sense? So let's say that Riley, Peyton, and Bella were one group. Okay, because it's a combination, order does not matter. So Bella, Peyton, and Riley would be the same group. Does that make sense? The order doesn't matter. So Riley, Peyton, Lex would be a different group. Does that make sense? So there are 120 of those different groups that we can make. Does that make sense to everybody? Okay. If we were doing like a permutation, okay, where Riley, Peyton, Bella is different than Bella, Peyton, Riley. So I was thinking like putting them first place, second place, third place. So let's say Riley's first place, obviously. Peyton second, Bella third. That would be different than Bella first, Peyton second, Riley third. Okay? And if we did that, you can see you'd have 720 different ways of doing it. Does that make sense? Okay. So we're interested in the 120. Now, if I'm going to multiply this by P, which was 0.2, and we're going to raise that to 3 because we wanted 3 successes. So if you go back to independent probabilities, if I flip a coin and I want to know what's the probability of getting like 3 heads in a row, it's 1/2 times 1/2 times 1/2, right? Does that make sense? Okay, so I'm multiplying those probabilities, independent events, by each other, and that's really what I'm doing right here. 3 successes, 0.2 times 0.2 times 0.2. But when I have 3 successes, I'm doing this 10 times, how many failures would there be? There's 7 failures. And then that exponent is representative or referring to the number of failures attached to the failure probability. And what this number right here says, 0.201, 0.201 is saying that there is a 20.13% chance that if I randomly take 10 people, that exactly 3 of them went to the doctor last month. Okay? That's what that's saying. Okay? I'd like to, I want to, because I think maybe it makes more sense to kind of investigate this using, and I don't know, we didn't spend a whole lot of time on the question with the quiz yesterday. I mean, we've been talking about this one. It's really the same situation. 10 questions. The other one had 10 people, right? The probability of success was 0.25 here. The other one, the probability of success was 0.2. So I'd like to talk about that scenario because the context of that I think makes a little bit more sense. If I were to, so I'm going to just use a Excel worksheet here to help understand this. If I were to go equals binom dist, which stands for binomial distribution, and the first thing it says number S. So number S stands for number of successes. So I'm just going to let that cell be the number of successes I want. 10 trials, and I'm going to do the 0.2 real quick just because I want to make sure that we realize that what we did by the formula is validated here, and we'll type in false. Okay, so this is the scenario, this is the question that targeted the people visiting a doctor. And that's what we just found out by hand, right? Would you agree that it's much quicker to use Excel to do that for us? Because generally speaking, they don't just ask us a lot of times, well, what's the probability of exactly 3? A lot of times they say, what's the probability of at least 3? Or what's the probability of at least 9? And so then we had to find multiple probabilities. And we had to run through that formula multiple times, where Excel allows that to be done for us a little bit quicker. Okay? So that should kind of confirm that we did that correctly. But now let's kind of augment this a little bit and go back to the question in which we were taking a multiple choice quiz, 10 questions, 4 options on each question. So when I do that and drag that down, the probabilities look like that. Okay? And what this means here is that I have a probability. If I go into that test and I take it blind, there is a 5.6% probability that I get 0 questions right. This is saying that there's an 18.77 chance that I get 1 question right, correct? Yesterday we asked what P of 3 was, and it was 25.028. And as you can see, it's still up there on the whiteboard. And we kind of talked about the scenario that if I knew that I had to get a 30% on that quiz to pass for the 9 weeks or pass for the year, that it's a 25% chance that I'm going to get that 30%, right? And that's actually a little bit false. because that's the percentage that that's the percent or the chance that I'm going to get just a 3. But if I get a 4, do I still pass? If I need a 30%, but I get a 4 on it, which would be a 40%, right? Do I still pass? Yeah, I did better on that test, right? So if I did better, I should still pass. So really the idea is if my goal is I need to get a 3 to pass, okay, exactly a 3 is that percentage. But if I get a 3 or above, so I'm just going to hit sum and add all of these up, there's actually a 47% chance that I could pass that class by just guessing on this quiz. Does that make sense to everybody? So you have to kind of weight probabilities and say, okay, well, what if I'm going to, what if I only need a 20%? So then I'd be adding those up, and it's a 76% chance, right? Some of you might be okay with saying, okay, well, I need at least a 20% on this test. I used to have people do this all the time. Obviously, they didn't sit and calculate this stuff. But when we gave finals and midterms for your non-college classes, people would say, I only need like a 10%, only need a 25% or whatever. I'm not going to study at all because the chances of me not getting 25 are pretty low. This is saying if you just purely guess, take out all logic, there's 76% chance that you're going to get that 20% that you need to pass. Some people are willing to take that risk, right?
I do it so much.
Okay. Now that being said, remember what this means. That means you are completely guessing on every question. You take a quiz and you know some of the material. Does that 75.5 increase because you know some of that material? Yeah, it should. Okay. When we look at this distribution formula in either Google Sheets or Excel, the last condition, so number of trials and then number of trials and the probability of success. The last one here, if you can see it, it says cumulative. I don't know why it's covering that up. There you go. Oh, it's still there. It says cumulative here. So I've been typing in false because I don't want it to be cumulative. But if I do want it to be cumulative, type in true. And the idea here, if I drag this through, now these last two are both not 1. If we format the cells, it's doing some rounding on its own here. So you see that this last one is not 1. But what's happening is this cumulative sum is just obviously the probability of 0 questions correct. Okay. This one here, this 0.244 number, is the probability of getting 1 or 2 correct. Does that make sense? Or sorry, 1 or 0 correct. So it's those two situations. So it's an or statement in our probability. Okay, so add those together, you see what happened. Equals, oh, I know what I did. So I didn't type in sum. Add those two together, and we get that number right there that's showing up, right? Okay, so that number is the sum of those two. Okay, so it's the idea what's the probability of getting 0 or 1 correct. If I want, so this number here is the probability of getting 0, 1, or 2 questions correct. Does that make sense? Okay, and obviously then it should make sense that this last one is 100%. There's a 100% chance that I'm going to get 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10 questions correct. Is it okay with everybody? Okay. So that's kind of the difference between the cumulative and non-cumulative scenario. Why would we be interested in that cumulative? What if I ask the question, what is the probability, let's see here. All right, let's go to this example. And this should allow us to look at the need for that cumulative function. All right. So as a survey from Teenage Research Unlimited, Northbrook, Illinois, found that 30% of teenage consumers receive their spending money from part-time jobs. So if 5 teenagers are selected at random, find the probability that at least 3 of them will have part-time jobs. Okay, so 30% of teenage consumers receive their spending money from part-time jobs. So that means the probability of a success, because that's what we're interested in, is that they have part-time jobs. That is 0.3, right? Q is 0.7. Okay, N, how many teenagers am I looking at here? 5. And then X for this particular question says at least 3. At least 3. So what's that mean? Can X be 3? And it could be 4, and it could be 5. So what we're looking at doing here is we're trying to figure out the probability of 3, or 4, or 5. So that means, if we wrote it this way, going back to the last chapter, 3, or 4, or 5, okay? And the idea that these are disjoint, they cannot happen at the same time, okay? This would mean that we're going to go with probability of 3 plus the probability of 4 plus the probability of 5. That's what we're looking for. Okay. Well, in each one of those, okay, this one here is going to be 5, choose 3, times then a success, which would be 0.3, raised to the third, times a failure, raised to the second. We should have 3 successes, 2 failures, right? This one here is going to be 5, choose 4, and then 0.3, 4 successes, 1 failure. And then this last one should be 5, choose 5. Okay, how many different ways can I have 5 things and choose all 5 of them? Just 1. Okay, 0.3, so I want all of them to be successes, and then no failures. So we had to find those 3 things, okay? Which would not be, I mean, that's not I think a ridiculous task if we were maybe going back to, instead of having 5 being the discrete variable that we're looking at, or n, let's say this was like 12, and then I asked you, well, what's the probability of at least 3 there? Would you want to do that all the way up through 12? No, okay. I think we probably, with 3 or 4 things, we kind of hit our limit of wanting to do this by hand. We should be able to calculate those. I'll show you, like Desmos, again, allows for this to be done pretty quickly. Because of the ability to kind of edit once you have the formula typed in. So I'm looking at NCR. Try to get this. There we go. So NCR, so we're looking at 5. Choose 3. A success is 0.3. A failure is 0.7. We want 3 successes, and we want 2 failures. So the probability of 3 would be this 0.1323 number, right? Okay. Okay, now if I want a 4, okay, so I just go through and edit then. Basically change the 3s where they were to 4s. And I get that 0.019 number. Oh, yep, I'm going to change that. Thank you. There we go. So your exponents, hopefully, because one was n, one is x and one is n minus x. Hopefully we realize that the exponents need to add to n. So in our case, n was 5. So we get that. And then the last one, 5, choose 5. 5 successes, no failures. And we get that. So now what are we going to do with those 3 things? We're going to add them together. Okay, so we can couple different ways we can do that. Control C, Control V, plus Control C, Control V, plus and Control C, Control V, and we get 16.308. So there's a 16% chance that at least 3 of them have part-time jobs. Now, that's nice, and we can do that by hand, but let's look at how much more efficient Excel is. Okay, so I'm only worried about going up to 5. So delete all that stuff out. My binomial distribution now is, okay, still going to have this as my discrete variable. So that's my number of successes in this case. Trials was 5. Probability of a success was 0.3. And I'm going to type in false right now. And if we look at those, okay, and now just, if we want at least 3, we could sum those up. We get that number right there, right? Okay. Now, if, let's say, I think the question I ask here, is there a more efficient way to do this? Let's say that we're doing this by hand. And there we had to find 3 things, right? If I say at least 3, is that equivalent to 1 minus the probability of being not at least 3? That kind of makes sense? So what's the probability of being not at least 3? Which situations are we talking about there? 1 and 2. Okay. And actually this case, because of the odd number of n, it'd be 0, 1, and 2. So it's really the same amount of work because you got 3, 4, and 5 that we did, right? But if it was an even number, you could kind of maybe expedite your work with something like, so let's do it this way. Let's say, what is the probability of at least 1? If I say at least 1, okay, so I would be summing these up, right? If I said at least 1. So let's go and look at that sum, which would be that number right there. So at least one of these students or teenagers has a part-time job at 83%. Okay? Well, that is the same thing then as 1 minus the probability of 0, right? The probability of 0 would be this one here. So if I take 1 minus that value there, does it still give me the same 0.83193? Okay. So why would I want that? Well, the binomial distribution, if I want to go with the cumulative approach, what it's doing is it's adding all of these up, right? So if I want to say what is the probability of at least 2, okay, well then this is the cumulative for up to 2, right? Or I guess, yeah, up to 2, including 2. So what I would want to do then is subtract those from 1, and should give me the same results. Does that make sense? So the cumulative function, I like, I mean, it's there, it's nice, but I prefer to do cumulative, get these individual probabilities, and then get the cumulatives by using the sum technique, the sum function. But you can, there's a lot of functions inside Excel that last condition will say cumulative, or it'll say something like that where you got to type in true or false, and then it differentiates whether it's going to how it's going to analyze or apply that function. So just be careful with that. Is that okay? I don't foresee you guys having your computers back anytime in the near future. I would think middle to maybe late next week. We got an email today. They're starting to, like, I got my computer back, but I know there's still teachers out there that still don't have their computer fixed. So, and all the computers that were turned in are still over there. So that's, I think, kind of where we stand right now with computers. My goal is just to kind of give you guys a heads up. The end of the semester shows up or ends up being the 14th. We will have a midterm, okay? So it's going to be probably the 13th and the 14th. It'll be both days. The plan is as well to, before we go on Christmas break, to have some type of assessment. I don't foresee it as being like a full out exam. We've only talked about 3 sections right now. And we're going to get into, later this week and early next week, into normal distributions, which is a very critical point of this course. So I think we should assess over that on probably Thursday of next week. So it's chapter 4 up to what we cover in the rest of this week and next week. Is that cool?
Cool.
All right. I am going to